Hi everyone, welcome back to Quantify Your Career. And today we'll be solving an interesting brain teaser problem. Now let's try to understand what the problem is. So imagine you're walking down a hallway with 100 doors and all of them are closed in the beginning. So what happens during each of those 100 passes? You pass by each door 100 times. So in the first pass, that is the first time you pass by each door, you open each door. In the second pass, that is the second time you pass all the doors, you only stop at every second door and then you toggle that door. Meaning if it's open, you close it. If it's closed, you open it. So you stop at door number 2, 4, 6, 8 and so on, and you toggle that door. In the third pass, that is you go back to the start and start walking the hallway the third time, you stop at every third door and then toggle it. Means you stop at door number 3, 6, 9, 12 and so on, and then you open if the door is closed and close the door if it's open. And you do this like 100 times. And on each pass, you follow that rule of stopping at doors whose numbers are multiple of that pass number. Like I said, for example, in the third pass, you stop at the door number 3, at door number 6, door number 9, door number 12. These are all multiples of the third pass. So the question is, by the end of 100 passes, which doors are still open? And remember, all the doors are closed in the beginning. So let's try to find a solution. So let's simplify this problem. Assume you have 10 doors and 10 passes. That is, you pass by each door 10 times instead of 100. So what we see is, on the top row, you have 10 doors. On the left column, you have 10 passes. You pass by each door 10 times. Now the initial state, just observe the second row. Every door is closed in the beginning. Now, on pass 1, you open each door. Since you toggle each door at pass 1, you are opening each of the doors. In the second pass, you toggle every second door, like I had mentioned. So 2, 4, 6, 8, and 10 are now closed. You're changing the state of the door. Take, for example, the fifth pass. The fifth pass, you close the fifth door and open the 10th door because you're changing the state from the earlier state. And going along the passes, the 10th door, in the 10th pass, you only toggle the 10th door, so you close the door. That is, change the state. So what you observe here is that the door number is divisible by the pass number. So for example, you can take door number 6. It is divisible by pass number 1, pass number 2, pass number 3, and pass number 6. That is when you toggle that door number. So getting back to the question was at the end of 100 passes, in our case at the end of 10 passes, which doors still remain open? Which is door number 1, door number 4, and door number 9. So if you observe a pattern in these door numbers, these are perfect squares. So that is actually your answer for the 100 doors problem. The door numbers with perfect squares remain open. Now let's see why that is the case. So if you observe, most of the doors have an even number of toggles. For example, door number 6 has 4 toggles, open, close, open, close. That's an even number of times. But the perfect square numbered doors have an odd number of toggles. Door number 1 has 1. Door number 4 has 3 toggles. Door number 9 has 3 toggles. These are odd number of times the door has been toggled. Why that is the case? Now let's focus on the bottom row. These are the divisors of the number of doors, of the door number. That is, the door is divisible by these divisors or these numbers. For example, door number 5 has 2 divisors, 1 and 5. Door number 6 has 4 divisors, 1, 6 and 2, 3. So 2 pairs. Door number 9, it has 3 divisors, 1, 9 and 3. Because it's a perfect square, 3 is not repeated twice. So this has an odd number of divisors. And all perfect squares like 1, 4, and 9, these all have odd number of divisors. That is why the doors are toggled odd number of times. And so if the initial state of the door is closed, it will always remain open at the end because of the odd number of times it has been toggled. So this is it. In the case of 10 doors and 10 passes, there are 3 doors which remain open because there are 3 perfect squares. So the answer to your question of 100 doors is 10. 10 doors will always remain open because of the perfect squares 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. These are all perfect squares and they will always have odd number of divisors and odd number of toggles. So I hope this solution helped you, and if you have any questions, please mention in the comments, and stay tuned for more such solutions of brain teaser problems, which are not just in quant finance but also in data science interviews. And also check out our LinkedIn page for more such problems and solutions. The link is in the description. Until next time.